This lesson is on linear and quadratic systems of equations. Recall that a system is where there are two lines or equations graphed on the same coordinate plane, and a system we're going to look to see for the solutions where they intersect. Okay, so let's get started with an overview. We're going to learn through substitution. What we're going to do is step one is always going to be to solve one of the equations for one of the variables. Typically, I would solve for y. Step two, I'm going to substitute the expression from the first step into the other equation in order to solve for that other variable. Okay, typically that will be x is what I'm going to try to look for second. And then lastly, I'm going to substitute the answer from that second step into the original equations to solve. So the same way we solve linear systems of equations, we're going to do it with quadratics and a linear. All right, so then graphing will look like, here's our quadratic, there's our parabola, and our line. There's our linear and our quadratic. Here we have two solutions. That's where both that of the intersection points that the line cuts through that parabola. So in this case, we have -2, 4, and 1, 1. Those are solutions to that system. Here, I have one solution. In this case, it is -1, 1. And then where they do not intersect at all, this will be no solution, or no solutions. Okay. Substituting is very simple. In step one, we said we're going to take one of the expressions and substitute it in for the other variable, or the variable that you have. I have y by itself, so I don't have to solve for anything. I'm going to take that and plug it right back into what y is. So now I have 2x minus 4 equals x squared minus 4x plus 1. And since I'm not going to move this x squared to the left because it'll become a negative, I'm going to leave it over here and move everything else over to make it equal 0. So I'm going to add the 4 to get it onto that side of the equation, and I'm going to subtract 2x to move it onto that side of the equation. So I'm left with 0 equals x squared, -4 minus 2 more is -6x plus 5. Okay? Then what I'm going to do is factor to find my solutions. I know that I'm going to have two binomials. Two numbers that multiply to 5 but add to -6 will be x minus 1 and x minus 5. And then I'm going to solve by setting each of those equal to 0. X minus 1 equals 0 and x minus 5 equals 0. So my x variable or values, I should say, I'm going to add 1, and this x value will be 5. That's the first step in finding the solution to those points. The first one has an x value, and the second point has a 5 for that x value. So now I'm going to go back up and take my x's and plug each of them in to solve for y. So I'm going to pick the first equation just because it's much easier. I don't have to deal with anything squared. So y equals 2 times, I'm going to plug in this x, 1 minus 4. So 2 minus 4 is -2. So when x is 1, my y value is -2. All right, same thing. I got to plug it in for 5 to find the other solution. Y equals 2 times 5, just plugging it back into that first equation, minus 4. 10 minus 4. When x is 5, the y value is 6. Those are the two solutions to that linear and quadratic equation. So example 2, again, we're going to substitute in. I have already have y solved for, so I'm going to go ahead and plug it in for my y value. Negative x plus 5 equals negative x squared minus 4x plus 5. This time what I'm going to do, so I don't have this negative, I'm going to move everything onto the left side of the equation. So I'm going to add x squared. I'm going to add 4x. And I'm going to subtract 5. So now nothing's left on that side. They all canceled out. I have x squared plus 3x. Oh, but then nothing. Plus 0. Don't even need to put it though. So now what I'm going to do, I have a GCF I can take out. I can pull out an x. That's how I'm going to solve for this x. I'm going to pull out what I can. I'm left with x and plus 3 equals 0. So again, I'm setting up two equations. I have x equals 0, and then x plus 3 equals 0. So here's one of my x's, and then solve for the other by subtracting 3. X equals negative 3. That's the first step in my answers. I have 0 and negative 3. And I got to find the other part of each of those points. I'm going to plug each of those back into the first equation. So y equals negative 1 times 0 is 0, plus 5 is 5. 0, 5. And do the same thing plugging in negative 3. So negative times negative 3 plus 5. That's 3 plus 5, which is 8. Okay, I'm going to pick up the pace a little bit to get through graphing. Okay, now instead of substituting, what we're going to do is graph on our coordinate plane to find where those 2 points intersect. I can easily go ahead and graph that first line. Remember, this is my y-intercept and my slope. Start at negative 3 on the y-axis, down to right 1 or up to left 1. Go ahead and graph that. That's easy. Now I have to graph my parabola. What I'm going to do first, recall back in your yellow foldable, solving quadratics by graphing. All right, that will help you remember. We're going to find our axis of symmetry. Remember, that's when x equals negative b over 2a. If you don't remember this, go back and look at that yellow foldable. X equals the opposite of b is negative 4 over 2 times a is 2. So negative 4 over 4 is negative 1. Now I got to find the vertex of my parabola. I'm going to plug in what x is into my equation. So 2 times negative 1 squared plus 4 times negative 1 minus 3. Y equals 1 squared is 1, 2 times 1 is 2, 4 times negative 1 is negative 4 minus 3. So y equals negative 2 minus 3, or negative 5. That's my vertex. Negative 1, negative 5. Now don't forget, you got to set up your table, your x and your y table. I'm going to put my vertex in the middle. And I'm going to pick 2 points on either side of that axis of symmetry. So I'm going to go to negative 2, negative 3, and I'm going to go to 0 and 1. Plug in 3 for each of those x's up in here. To solve for y, it'll give me 3. Plug in negative 2, it'll give me negative 3. Plug in 0, it'll give me negative 3, and plug in 1, it'll give me positive 3, and go ahead and graph those. I'd graph it in another color if you have one. So negative 3, positive 3, oh, here's a point, that's a double point. Negative 2, negative 3, -1, -5, 0, -3. There's a double point. And then 1, 3. There's my parabola. And I have two solutions, right here and then right here. My point is -3, 3 and 0, -3. Those are the points of intersection. Oops, sorry. Okay, very good. Let's do example 4. Again, first thing I do is go ahead and plot your linear equation. I know that's the linear. I'm going to start at +4 on the y-axis. That's my y-intercept. And my slope, -1/2. So down 1, right 2. Down 1, right 2. Or up 1, left 2. Okay? Good. And again, refer to that yellow foldable. I'm going to have to graph that quadratic. First, solve for your axis of symmetry. X equals -b, or opposite of b, over 2 times a. The opposite of b is +2 over 2 times -1. 2 over -2. My x value is -1. Substitute it back into that equation. Negative times -1 squared minus 2 times -1 plus 2. Negative times 1 plus 2 plus 2. So -1 plus 2 is 1, plus 2 more is 3. And go ahead and set up your x and y table, putting that vertex somewhere in the middle. And I'm going to go 2 points below it and 2 points above it. Plug in -2 to that equation will give me +2. Plugging in -3 for each of the x's will give me -1. Plugging in 0 will just give me 2. And plugging in 1 will give me -1. And go ahead and graph, and we're going to see where our solutions are. -3, -1, -2, +2, -1, 3, 0, 2, and 1, -1. I notice here there is no intersecting points, so this has no solution. Okay. It's important that you guys are able to do this by hand, but we will learn the calculator trick as well, to just put this in our calculator and find out where the solutions are, if any. There is no left-hand page. Please email me if you have questions. And the code word, I forgot, of course. The code word is iPhone.